here, plus 2cx. Okay? I think I should check all this.
Okay. A plus between the a and the e to the 2x.
Yes.
Looks like it's
Thank
multiplying.
you. Okay. And then we do one more differentiation. Yp double prime equals that differentiates to 0. Differentiate e to 2x, you get e to e to the 2x times that stuff in parentheses. Okay. And then e to 2x and differentiate the parentheses. That's going to give me just 2c. And again, I simplify this as much as I can. I'm going to have an exponential of 2x. Oh my goodness. So you see I pick up a 2c plus 4d plus 4cx, right? And here I get a 2c. Obviously, you want to combine these two c's to be a 4c, right? So we'll just take this guy off and make this a 4c. Okay. And then now I'm just going to try. I'm not going to write this and just bore you to death. Okay. What you do now is you do L operating on yp, right? What would happen? Yp double prime, the last line, right? Minus 2 parentheses yp prime, which is up here, quite a bit, right? And then minus 3 times yp. So minus 3 parentheses, all those terms. And clearly what you want to do is you look at the right-hand side, and I should basically get the constants together, the power of x, x to the first, and e to the 2x and x e to the 2x, okay? Let's see what happens. Let me just write this down, okay? This part I did in real time, so don't trust me on this, check it. But this I checked, so I'm right now basically, unless I transcribe it wrong, is correct. I have 3ax plus 3b plus 2c wait a minute, what problem am I doing? I'm probably doing the wrong thing. Oh, just give me a second over here. This is example number 3. Oh boy. Sorry for that. Problem number 3. I'm going to get minus parentheses 2a plus 3b. That's the constant term. Then I'll pick up a linear guy that's minus 3ax. Then I pick up a minus 3cx times the exponential of 2x. And then, finally, 2c minus d, 2c minus 3d, exponential of 2x. Just make sure I got that right. Now minus parentheses 2a plus 3b for the constant term. For the linear, I get a minus 3ax. Then I get minus 3cx e to the 2x plus paren 2c minus 3d e to the 2x. And that has to be identical to the right-hand side, which is 4x minus 5 plus 6x e to 2x. Okay? At least I get the A right away, right? Okay. So, what do we have? This guy has to equal -5. So we have an equation 2a plus 3b is equal to 5. Okay. If we match the x ones, that one we can do right away. It's isolated. We get minus 3ax equals 4x. So a has to equal minus 4/3. You get that right away. Right? Okay, and then you match coefficients of x e to 2x, that'll give you the c right away, right? Minus 3c is equal to 6, so c is equal to -2. And then I have everything except d, and how do I get that? Look at the right-hand side. Notice that the right-hand side has 0. There's no e to 2x on here. X e to 2x, x e to 2x. But there's no coefficient of just a constant e to 2x on the right, so therefore 2c minus 3d is equal to 0. And when you put that all together, you find a is minus 4/3, okay? You'll find out that capital B is equal to 23/9. C is -2, we saw that, right? And D is just -4/3. Okay. So finally, we can write the particular solution, y sub p of x is the complementary yp of x. Just plug in your coefficients. What do I do for yp of x? ax plus b, so that's -4/3, right? See, -4/3. So you get -4/3 x plus b, which is 23/9, plus cx equal to 2x over c2, minus 2x exponential of 2x. And then d e to minus 2x, which is -4/3. E to 2x. Okay? So, you got your complementary, you got your particular, and the general solution, y of x, is just the sum of the complementary solution, y sub c, plus y sub p of x. Right? And of course, we're not given any initial conditions in this problem. Therefore, we have two arbitrary constants in the general solution for y of x coming from this guy over here. And to get those again, if you have initial data, you can find C1 and C2. Okay. Any question on the general procedure? I think it's pretty clear what we do. Okay, we basically all these equations we solve the associated homogeneous. Okay, which hopefully that's under our belt. You know how to do all the cases there. Okay, and then we look at the right-hand side, and if necessary, break it up into pieces and get the family of the right-hand side, and then look carefully to make sure that no member of the family of the right-hand side is one of the homogeneous solutions. Because then this is going to drop out. Okay, and we have to know how to address that. Am I getting to that yet? Example number 4. Yes, example number 4 is finally one of those. So we have to now go to part 3. Okay, I think we'll do example number 4 first, and then we'll look at it. It's kind of wordy, but you'll see what's going on. I think it's much easier to just see a thing in a problem as the general theory. And again, on an exam, I mean, you may say, oh, it's algebra, and I'm not bad at algebra, I'm going to screw up. Okay, I'm more interested in the technique, okay? If, you make a mistake somehow, it should be a 2A and make it a 6A, and therefore everything else is wrong, you still could get, 19 out of 20 points, okay? As long as everything is consistent, okay? Again, it sounds ridiculous, but to me, the answer is the least important thing. Let's make sure that you follow a method that makes sense over here. Okay, so here's the differential equation. It's second order. Y double primed minus 5 dy dx plus 4y is equal to 8 e to the x. That looks pretty simple, right? 8 e to the x and right-hand side isn't that bad. Okay, so first thing, solve the homogeneous equation. Okay, well, that's going to be y double prime minus 5y prime plus 4y equals 0. I know how to do that. I look for r squared minus 5r plus 4 is equal to 0. And that factors into r minus 1, r minus 4 is equal to 0. Okay, so the roots, the first root is r equals 1, and the second root is 4. Great, distinct roots. Okay, so e to the x and e to the 4x. So the general solution of the the general solution of the associated homogeneous equation is some arbitrary constant e to the x plus another arbitrary constant e to the 4x. Okay. Now, this we got to be careful and pay attention, right? Notice that the general solution is a linear combination of e to the x and e to the 4x, right? So if I plug into this equation any multiple of e to the x, what's going to happen? It's going to go to 0 because it's a homogeneous solution. Now look at the family of the right-hand side. It's e to the x. Okay? So you would say, oh, well, I'll do like I did in the other problems. I'll set y particular. The family of e to the x is easy. A e to the x. What's going to happen? I can tell you can do it, but I know already what's going to happen to A e to the x. It's going to drop out completely. And then what's going to happen is you're going to have 0 equals A e to the x. Okay? Because what we did, there's nothing inconsistent over here, we assumed that the particular solution had this form, and now it doesn't, okay? And again, this is not, it's not like sometimes it does, sometimes it doesn't. There's a reason for this, okay? What happened in this case is that when we looked at the family of our right-hand side, which in this particular case is e to the x, that was one of the homogeneous solutions, okay? So I'm not going to go through the proof, but it's very similar to what we did before when we had a double root. All you do is throw in an x factor in there. Make it ax e to the x. Okay, that's no longer a homogeneous solution. And magic, you'll see that I'll actually be able to solve for the numerical value of a. Okay. Now, someone should ask the question, what happens if I had a differential equation, okay, and the homogeneous solution had as solutions e to the x e to the x, and the right-hand side was e to the x? Well, now when I make the particular ax e to the x, that's a homogeneous solution, just go to 0. You know what you do? You just make it x squared e to the x, just like we did for the triple root case, okay? And clearly it's always going to work because, I don't care how many x e to the x is, x to the 5th e to the x, maybe you had 12 roots, and e to the x was a solution, x e to the x and x to the 12th e to the x, you'll make this x to the 13th e to the x. It will always be able to find a particular solution no matter what happens to the homogeneous, okay? But again, that's why I think you can understand now why I said always solve the homogeneous first, okay? Because in cases like this, where the family of your right-hand side happens to contain a particular solution, a homogeneous solution, it's not going to work. It's going to drop out. And then invariably on exams, I get people, they'll say, well, I put in family of e to the x, and then my A dropped out. What happened? Well, it was the homogeneous solution, okay? It's a very easy mistake to make, okay? But once you get into the habit, basically, first solve the homogeneous, get the family. As soon as you get that family, check back to make sure none of the family members are in the homogeneous solution. Then you can just proceed as normal, okay? If you do, like in this case, find that the particular solution has a family member that's in the homogeneous set, just hit it with the power of x until it's no longer a member of the family. Now, in this case, don't do x squared e to the x, okay? You use the lowest power of x that you can to get it out of the homogeneous solutions, okay? And therefore, now we can read number 3, even though it's a little bit wordy. Let's see what it says. Okay, if any family member has a member which is a homogeneous solution, see here I did a very simple example. It's only one family function. But the right-hand side could have been something like 8 e to the x plus 12 cos x, maybe something like that. But if any family has a member which is a homogeneous solution, that's exactly what we have now, replace that family by a new family in which each member of the original family is multiplied by x. Here there's only one member of the family, so it's x e to the x. Or by the lowest integer power for which no member of the new, it's kind of wordy, but it's exactly what I said before, okay? But then I have a little note over here. It should also be noted, for example, that the presence of e to the x assigned to the homogeneous. Okay, yeah. Suppose you had a differential equation, and part of the homogeneous solution, you had homogeneous solutions e to the x and sine x. So we had c1 e to the x, maybe c2 sine x, okay? And suppose the right-hand side was e to the x times sine x. You don't have to modify that, because e to the x sine x is not e to the x, it's not sine x, right? That's completely different. So in that case, you wouldn't have to modify the family. It's only when you get a function, like in this case, like e to the x, that's, you see it's right in the homogeneous solution that you have to modify. Okay? So let's now do this and see what happens if we actually can solve for the coefficient. Okay, there's the complementary. Okay? I don't have any notes on this, I'm just going to have to do it. Okay? I don't have any intermediate results. So hopefully I'll do it with the board. Okay, what's yp prime? You use the product rule. It's a e to the x plus ax e to the x, right? Which I can factor out in a e to the x, right, times 1 plus x. Okay, what about, I guess we'll have to call it quits at this point. Yp double prime Okay, you differentiate this guy, you get AE to the x times 1 plus x, right? I differentiate that guy, AE to the x 1 plus x, plus AE to the x times 1, right? Because AE to the x times the derivative of 1 plus x. So yp double prime is, let's factor in AE to the x. Here I get a 1 plus x, right? Plus another 1, right? AE dx 1 plus x plus that, which are just AE dx, parentheses, 2 plus x, right? Okay, let's quickly do L operating on yp, let's see if we can solve. L on yp double prime, so it's not too bad, it's AE dx times 2 plus x, right? Minus 5 times the first derivative, what's yp prime? AE to the x 1 plus x minus 5, AE to the x 1 plus x, finally plus 4 times the particular. And the particular is AX e dx. Okay, let's clean this up. L operating on yp. And I can factor out in AE dx on everything, right? Here we get a 2 plus x. Be careful over here. I factor out AE dx negative 5. Negative 5, negative 5x. And then factor out AE dx plus 4x. Okay. So what's L operating on yp finally? It's AE to the x. What I have in parentheses? 2. The x stuff goes out. 4x plus x is 5x minus 5x. I get 2 minus 5, which is just negative 3. Right? Everybody see how the x stuff goes out? Isn't that interesting? You only have one, see, it's interesting, you only have one coefficient. So it's not like before, if we had a residual of x e dx, like I said, equal to 0. So it's no accident that the x cancels out. And then on the right-hand side, you have 8 e to the x. So it's clear, therefore, that A is minus 8/3. So the particular solution in this case is minus 8/3 x e dx. Okay. And therefore, the general solution to the equation y of x is the homogeneous solution c1 e dx plus c sub 2 e to the 4x. I'm writing them all out because it's not that bad.